All right, guys, so 3 more examples of practice of these antiderivative skills, and then tomorrow we're going to do a new lesson that extends all of this knowledge. So hopefully this repetition is helpful and you're getting some time to do the bookwork. And that bookwork is due Friday. All right, so tonight you are not going to have homework. You're just going to have the opportunity to continue working on the bookwork. So you should try to do this one on your own, and I think you probably can do this one on your own. It's very similar to some of the other examples. And again, the skill here that you're going to want to apply is take this fraction and turn it into 2 separate fractions. Okay, so when I take the antiderivative, I'm going to want to look at it like this first. 2x over 2 to the x, or times x to the 1/2, plus 1 over 2 times x to the 1/2. Okay, so then I probably want to rewrite this again. These 2's will cancel, and x divided by x to the 1/2 is going to be x to the 1/2, so that first term comes out nicely. And then in the second fraction, I would rather write this as 1/2 times x to the negative 1/2, which is really just me taking this x to the 1/2 and moving it to the numerator, leaving that 1/2 there. All right, so now that it looks like this, I can apply my reverse power rules here. And so my antiderivative is going to be x to the 3/2, but remember that's going to have to cancel. So divided by 3/2 plus, so in this term it's going to have to be an x to the positive 1/2, and when I bring that 1/2 down, it's going to have to stay there to leave that 1/2 behind. All right, so that's all going to work out fine, plus c, and I'm just going to rewrite this because I'm dividing by a fraction here, so I'd rather multiply by the reciprocal of that. And the best way to write this as a final answer would be 2x to the 3/2 over 3, or 2/3 x to the 3/2 plus x to the 1/2, or you could write it as the square root of x plus c. Okay, so now we'll do a couple examples where we can actually find the exact function. All right, so this time you're given the second derivative and you're asked to find f, so you're going to have to jump up 2 more functions, right? We're going to have to find the first derivative function, and then we're going to have to find the original function. And we're given 2 initial conditions, which is important because if we are down here in the second derivative, we're going to need a lot of information to find all the constants we need to get that first derivative and then to get the original. So I think once we find our first derivative function, we're going to want to use this piece of information here because this tells us that f prime of 0 equals 2. So we'll cross that bridge in a minute when we come to it. Again, I would pause the video, try to do it, and then check your work with me. Okay, so when I take the first derivative here, this thing looks like it's in good shape right now. I don't have to really rearrange it. I'm going to have a 1x minus, and this is going to have to be an x squared term. What times 2 gives me 6? That's 3. Plus, this is going to have to be an x to the 3rd term. 3 times what gives me 48, okay, plus c. And it wouldn't be a bad thing to get in the habit of rearranging this to be in standard form, minus 3x squared plus x plus c. And that's just so that we get used to seeing these the way that we're used to seeing them. But now we have a piece of information that's going to help us here, and that's that f prime of 0 equals 2. So now I'm going to do a little work. F prime of 0 is going to be equal to 16 times 0 to the 3rd minus 3 times 0 squared plus 0 plus c, and that all has to equal 2. And whenever we're given something of 0 information, that's nice because all of these are zeros. And so what we've shown here is that c has to be 2. So now I can be confident in writing the exact f prime of x function with the constant filled in. And that's nice to have that information now because we have to find f, so we have to go up one more. We have to take the antiderivative of f prime of x, and that's going to give us f of x. Okay, so this first term is going to have to be to the 4th. What times 4 gives me 16? This is going to have to be to the 3rd. And what times 3 gives me 3? That's going to be a 1, so I can leave that one alone. plus, this is going to have to be an x squared term, so I'm going to need to divide this by 2 to get those 2's to cancel, plus 2x plus c. Okay, and then we're given a piece of information that's going to help us, and that's that f of 0, and this is my f of x function, has to equal 1. So I'm going to do some work here to figure out what c would have to be. Well, f of 0 is going to have to be 4 times 0 to the 4th minus 0 to the 3rd plus 1/2 times 0 squared plus 2 times 0 plus c, and that's 1. And so this is 0, 0, 0, 0, c equals 1. So now that I know what that constant value is, I can write my final function, f of x. And f of x is equal to 4x to the 4th minus x to the 3rd plus 1/2 x squared plus 2x plus 1. So we had to use 2 initial conditions there to get us to that final answer. Hopefully you figured that one out on your own. If you didn't, I'm thinking this probably made sense and you thought that you could have done it on your own. And so now you get the opportunity to try one more by yourself. We're going to do our third example, which is very similar. So pause this video, try to do this by yourself, and then press play and make sure that you did it correctly. So we are given 2 initial conditions to go with this second derivative function, but they both refer to the original function. Neither of these is an f prime of x initial condition. They both refer to the original, not the first derivative or the second derivative. So we're going to have to work our way up to the original function, f of x, with constants in places that they need to be, and then we'll have to figure out what those constants are once we get there. So f prime of x is the first function we need to find. This is going to have to be an x to the 4th term. The 5 should stay here, but I'm going to put a 4 down beneath so that when I bring the 4 down they cancel and I get a 5x to the 3rd. Plus, this is going to be an x to the 3rd, and I can leave a 2 there to create the 6 for my coefficient, plus 2x plus c, and I'm going to put c1 because I am going to have another constant when I find my second derivative. So since I don't have any information here and any initial conditions that help me find c1, I'm going to have to take another antiderivative with c1 being any possible constant. So now I'm going to find f of x, and this gets a little more challenging because now this is going to be an x to the 5th, and I have to ask myself what would have to be here for this 5 to come down and create a 5/4. And that's going to be a 1/4. And so you could do a little check there to make sure that that's correct, but if I take the derivative with respect to x of 1/4 x to the 5th is going to come down and I'll have 5/4 x to the 4th. So that will be that term that we had there. Okay, so let me try to make some space. All right, just trying to get the pen to work. There we go. Plus x to the 4th. And I want there to be a 2 here when that 4 comes down. So I'm going to leave the 2 there and let the 4 cancel with that 4. But you should be recognizing that this is going to reduce to 1/2, and it will. Okay, then we're going to have plus an x squared, which is fine because when that 2 comes down it can stay, plus the first constant times x, plus now we have a second constant. I'm going to rewrite this so that it just looks a little neater. So f of x is equal to 1/4 x to the 5th plus 1/2 x to the 4th plus x squared plus the first constant times x plus the second constant. And that is the general form for our original function. But now we've got to use these initial conditions to help us figure out what those constants are. And I'm going to use this initial condition first because zeros are really nice. That's going to allow this to cancel, this to cancel, this to cancel, and this to cancel, which is what I need to happen because I want this first constant to go away if I'm going to have to solve for this second constant. So I'm going to use that first initial condition. F of 0 equals 1/4 times 0 to the 5th plus 1/2 times 0 to the 4th plus 0 squared plus the first constant times 0 plus the second constant, and that all has to equal 3. And we see these all go to 0, so the second constant has to be 3. So now I can rewrite my function one time. I'm just going to pause the video and do that because it's starting to get a little long. Alright, and now I can use my second initial condition and plug in a 1 to each of these spots and set this thing equal to -2. So now we're just going to solve this. It's going to involve a lot of fraction addition here, so be careful with your operations. So this is going to be 1/4 plus 1/2 plus 1 plus what turns into just the first constant plus 3, and that equals -2. And you could add all those fractions together. You'd want to get a common denominator and subtract them from both sides. I'm just going to show you what this would end up becoming just to prevent this video from getting too long. But once you combine all of these under a common denominator, which is going to end up being 4, and get a common denominator here, you're going to find that that first constant is -27/4. So now that you've got that first constant, you can rewrite the original f of x function with the constants filled in. So f of x would be 1/4 x to the 5th plus 1/2 x to the 4th plus x squared minus 27/4 x plus 3. Alright, so make sure that you finish that book homework that goes with this section. Tomorrow we are going to do a new set of notes talking about specifically about position and velocity and how that works into all of this.